Hi, this is Lou. Today I'm going to talk a little bit about AC drives. We have customers that sometimes their fuses blow, input fuses, coming into the drive, and they're not sure if the drive is okay to power up. And I want to walk you guys through a little bit of a quick test. We call this a static check. So I'll be showing you guys how to check your drives today, so you guys know how to if you guys can power the drive back up or not. So stay tuned and follow along, and I'll be teaching you guys that today. All right, so let's talk a little bit about AC drives. Basically, AC drives are in all industries. Anything that has to move anything, whether you're moving a conveyor and you need to control speed, or a machine that needs to roll a roller, or a fan, or a pump. Well, it involves an AC drive if you're looking to control the speed of it. And sometimes these drives would trip, or they would blow a fuse to the input of the drive, and you're not sure if you should power up or not. But AC is definitely a widely used like drive in many different industries, and many type of people come in contact with these on a daily basis, and you definitely have to understand a little bit about it to troubleshoot it. So basically what it does is it will take, like in most cases, a three-phase input, and we're looking at maybe 220, 380, 460, 580 input in. And then once it takes that AC input in, it would rectify into a DC voltage. And then with that DC voltage sitting there, you have what we call chopping circuits. And basically what it does is it chops up your DC voltage back out to your motor. And I call it a fake AC, which you could control the frequency and vary the output voltage of it. So that's how you kind of control a AC motor, and you control that by AC drive. And basically that's what you do. So AC drive, you will have the keypad, which we normally call this local. If you want to control it through the keypad, is local. This drive here would have like some controls in here, and obviously I'm looking at a small drive because I don't have the capacity to videotape a big, say 300 horsepower or 100 horsepower drive. So this is a little small AC drive, and this is your control terminal, and we will call this your remote, because you could hook up your like push buttons, your start, your stop, your reference like 0 to 10 volt by putting a pot in there to control or vary your speed. And as you can see here, you can see some of the like what they call these right here as far as each terminal. And over here, I don't know if you can really see it, but you can see some of the wiring diagram. This right here, it could take a 380 or 500 L1, L2, L3, or RST. That's pretty common. And then you have your DC output, which is your bus voltage, and you have your positive and your negative, which is these two right here. They have PO and PA jump, and then your PB, and then your PC negative. And then your output is typically U, V, W, or T1, T2, T3. And over here, you'll see it could either be controlled with a 0 to 10 volt or a typically 4 to 20 milliamp. And then you'll have some relay contacts, which is here. And then you'll have your source as far as like how to control it, whether it's a 3-wire, 2-wire, or however you want to control it, start, stop, forward, reverse. But all that's not important. And obviously is missing a screw to your ground. But if you want to control it through other means of communication, here's a looks like an RJ, I think 45. I'm sorry, RS485 plug here to communicate to it. And this is a 10 horsepower drive again. And here again is your input. This is your input. This is your motor out, and this is your bus voltage. So you put 3-phase in here, and then it will be rectified, and then you get your DC bus out, and then you get your fake AC is what I call it. That your DC voltage is being chopped up and then sent back out to your motor to control your motor to either start it, slow it down, whatever. And that's basically how it works. So when a drive blows the input fuses, not necessarily on this drive, but from the input coming into the drive, it'll blow those fuses. And sometimes we'll have people call in or ask us like, hey Lou, it blew the input fuses. I replaced the fuses. I don't see any other problems anywhere, but I don't know if it's safe to power the drive, so I'm just going to take it out. And I'll say, well, there's a certain check that you could do. We call it the static check. It's not 100%, but it's good enough for you to power up the drive. And basically that's what I'm going to show you today on how to do that. So if you guys ever run into a situation where input fuses are blown, well, let's do this static check, and then I'll try to explain it of why I think is a good test for you guys to do while it's still in the machine. So I'm gonna kind of draw it out. Let me move this out of the way a little bit. And let me get my marker. So hopefully you guys could see this. Let's close this up. And basically you have your main input to the drive or your main power section, and that's with this static check. Basically that's what we're looking at for, is the your main power section, and we're seeing if there's any shorts in there. So when you put AC voltage in, it has to be rectified. And what does the rectification? Well, it's your bridge rectifier. So if we go in and draw it, if it's a 3-phase, these are your diodes. So this is your bridge rectifier. And then this is your input, your AC input. So basically what happens is during one phase of it, current will flow through here, through this diode on out, and you'll get one of your what I call AC positive phase, right? So that would be like L1 going in, and it will set that up, and then L2 would go through this diode here, and then it'll set up this one here. And forgive me for my lack of talent in drawing. So basically it will set that up, and then on an L3, right, which is the other phase of the AC input, you'll get it'll go through this diode here, and it'll set that up. And basically it'll just go through and it'll set that up, and then you'll have your positive on this side, and then you have your negative on this side. So basically that's what it's doing, is rectifying your AC voltage. I'll probably have a video that would go more in depth into that on the 3-phase rectification. But for now, just know that this is basically setting up your AC input, so that all your your sine wave is going to get rectified, and this pretty much sets up your DC voltage. And of course, you're going to get like a RMS out here, like a RMS DC voltage. So we'll do the VDC. It will set that up on here, and then the second part of your drive, you'll have what we call the bus capacitors. The bus caps. So again, AC goes in, it's going to get rectified through these diodes. It's going to set up your positive or negative voltage on here, which is going to go and supply your caps, and your caps are the one that's going to filter it and hold that charge and make sure that your DC voltage doesn't fluctuate, if just in case your input voltage takes a dip or something. So that DC voltage is sitting there, and remember that I said there's a circuit that chops up your DC voltage. Well, that circuit will be on another board, and I probably won't draw that, but that circuit is going to turn on what we call the IGBT, insulated gated bipolar, IG, insulated gated bipolar transistor. And basically, I'll just make it easy and we'll draw it like that. That's for one phase. And this is your, we'll call it your T, right? Because if you go here, you have T on 1, T2, T3. So T1. And then you're going to have another one here. So T1, T2, and T3, and all these are your output, and your chopping circuit or your firing circuit is what's turning these IGBTs on. But basically, this is your whole power section. And normally, when a drive fails or your main input fuses to your drive is open, it's more likely it has to do with this section here, right? This right here is going out to your motor. This is your DC side, and this is your AC input, which is rectifying your DC. So when your AC input fuses blows, is more likely is in this section here. That's maybe cause a short, but sometimes it could be something else, and we've seen it where something else has caused your input fuses to open up. And basically, what I want to, or the purpose of this video is to just kind of show you guys, hey, let's do a status check on this, and let's test our major power section of the drive to see if anything's shorted that might have caused it. And if nothing is testing defective, then we know that we could power the drive up. Okay. The best thing to do is take it apart and do a visual, but sometimes it's not possible, right? So when that happens, you want to basically just do a visual anyways. When you are looking at your drive, you want to do a visual. But in order for this test to work correctly, you would still have to take your wires out, not your control wires to your terminals, but your wires from your input. If you have a braking module for your braking resistor, it's best to take those out too, and take your three cables, wires to your motor, take those out too, so that you can get a good test on it. So what you want to do is basically, I'm going to set this here so you guys would see that, and then you guys want to turn your meter to the dial setting. Because if you look here, we have a diode here, we have a diode here, diode here, diode here, diode. And that's basically what we're looking for. And you have your positive and your negative. So your negative and your positive. And then these input here is L1, L2, L3 right here. And then your output is T1, T2, T3 is here. T1, T2, T3 again is these right here. So basically what we want to do is we want to make sure that these guys aren't shorted. This is not shorted, it's not shorted, right? We want to make sure there's no short from the positive to the negative. And we want to make sure that our diodes here on our bridge rectifier is not shorted also. And the way we do that is we'll just test it like we're testing the diode, right? I want to pull this up just a little bit. And if we're going to test this diode here, right, we want to put we want to set it to the diode setting on our meter. Make sure all the wires are pulled out. And then basically you want to test these diodes by putting the positive on the anode side, right? On the diode, we call this the anode side, and the cathode side. So basically what you want to do is you want to test this, and it'll give you like a voltage drop, which could be anywhere from like 0.3 to 0.7, but typically you're looking around 0.5 to 0.7 volts. So you're testing this one, you should see a voltage drop. Testing this diode, you should see a voltage drop. Testing this diode, and you should see a voltage drop. And the same thing on this one, right? I put the red on the negative, and then I'm testing each diode by moving my black lead to the AC input. And that's how I would go through and test each individual diode. Same thing over here. I'll put my positive here, and then I always want to put my negative lead, in this case here, on my positive, which is PA on here on this terminal. So I will put my black lead here, and then what I'll do is I'll touch T1, and I'll be able to test this IGBT here. So I should get I should get a voltage drop like I did with my bridge rectifier, and I shouldn't be seeing any kind of short. If I see a short or open, then I know I've got a bad module. So basically I would do tests here. I'll leave this on since all these are the same point, right? So I'll just leave it here and touch this, and basically test this transistor and test this here. I'm just I'm more looking for a short or a complete open. And then down here, I'm doing the same thing. All right, I'm putting my red lead on the black. This is one common point or node, and I'm putting it on T1, and I'm checking this one. I'm putting T2, checking this IGBT, and then put it on T3. I'm checking this one, and again, I'm emphasizing we're looking for a short or an open. And typically, it's not drawn, but what you will have is you will have a diode in here. And this diode is what you're basically reading. This is what we call flyback diode or a protection diode. And basically what it's doing is just there to protect each individual IGBT here. So we won't get too much into that. We could talk about that. Maybe I'll make a video on that one day when I focus more on diodes and purposes of diode and applications. But just know that diode is there, and that's what you'll be reading when you read that voltage drop. And as you go through each one, that's what you're reading is the diode on each one of these IGBTs. And again, we're just looking for a short or open, okay? And when we measure across our positive and negative, we're just looking to make sure that it's not open or short. Okay, so we are going to do a static check on this. So basically what we want to do is we want to start off with testing the top side, and we do that by putting the negative or the comment on the positive side. And here you can see PA, the positive, we want to put it there. And basically what you're looking for is consistency, and I'm looking for a voltage drop. So if I go through, I'm going to see a 0.48, 0.48, 0.48, and that's consistent. There's no short. And I'm going to test my output, which is T1, 0.35, 0.35, 0.48 and it's consistent. So basically what I'm looking for is that there's no open, there's no short. And basically what I just did was went through and tested my top side, my diodes, and my IGBTs on the positive side. Now what I want to do is I want to test the bottom side or the negative side, and I'm going to put my positive on my negative DC voltage output, which is PC-1, the negative. I'm going to leave that there. And again, I'm looking for voltage drop and consistency, okay? So L1, I got 0.438, L2, 0.437, L3, 0.438. I know that my diodes are checking good, there's no short, so my bridge rectifier is testing out good. And then I'm testing my output side, my IGBT, and the lower half of it. And I'm getting 0.342, 0.341, 0.339. So this tells me that there is no short or no open on my IGBT. So I would say that there's a very, very high chance that my power section is not shorted or open, and I could power my drive up. And one thing I really hate about these, if they come in as a package, because for your power section, if depending on the drive, they sometimes have the bridge and the IGBT in one module, and it could get pretty costly. It could be anywhere from like $300 to like $700 to $1,000 for a one package IGBT. Of course, the caps would be by themselves, but sometimes they do put them together, and then sometimes they'll put them separately. So you have your own IGBT in its own module, own package, and then your bridge rectifier would be by itself. And those are a lot easier and more cost effective. If the IGBT is the one that's done shorted out, we could easily just replace that, and the IGBTs will be left alone. And in some cases, the IGBTs, like each phase of these will be in its own package. So you have one IGBT, two IGBT, three IGBTs in there. So just know that when you look at those, it could be in different packages. So just keep that in mind when you're doing these testing, but the testing is all the same, even though they come in different packages. And this is basically how you would test a AC drive. And again, we call this a static check, and it's basically, again, testing all your major high voltage, high power components within your drive. And that doesn't mean that it's checking the power supply too, but it is checking your main voltage. So I just want to let you guys know that. If you guys have any questions, just shoot us or leave us a comment, shoot us an email, or reach back out to us somehow, and we'll be more than happy to walk you guys through this again or explain it in more detail. But to us, is a pretty good test. And once you get done with that and everything checks out fine, just put all your wires back in and make sure you put it in the right place and power back up. So I appreciate you guys watching this video, and I appreciate you guys if you guys would like the video. It would definitely encourage me to do more videos like this. Let me know that I'm adding value to you guys. So again, this is Lou, and thank you for your time and for watching this, and have a good day.